Greetings, and welcome to the presentation of the demonstration titled Deployment of Secure Machine Learning for Near Real-Time Control of 6G Network Services, to be presented at OFC 2024. Near real-time autonomous network operation is required to deal with the expected large traffic dynamicity required by beyond 5G and 6G network services. Centralized controllers can greatly reduce cost, but they might lead to inefficient resource utilization due to their long response times. To minimize the impact of the response time, control algorithms might be executed as close as possible to data plane devices. However, such distributed control solutions can bring security concerns as their exposed surface is higher than those of centralized ones. The main objectives of this demonstration are: show the integration between several components enabling the deployment of a secure mass pipeline, demonstrate the optimized deployment orchestration offered by the MLFO and the Alto server, and present the use of a DLT network for the key secret exchange among the agents. For illustrative purposes, we assume a network service requiring point-to-point and point-to-multipoint communications. This demonstration will show telemetry being collected and processed by the agents on top of the transponders. Two scenarios will be showcased in this demonstration. The first shows a distributed mass pipeline where each agent is in control of one of the transponders. The second shows a more centralized approach where a single agent is in control of all of the transponders. This figure shows the proposed architecture for the deployment of secure mass pipelines. The architecture is composed by several components: the MLFO coordinating the deployment of the agents and their configuration, the Alto server, which contains information about the topology, the computing resources available, and the network characteristics. Open source Mano is the selected orchestration system in charge of the deployment of the network service. Open Daylight SDN controller is on top of the packet network and is used to create the connectivity for the agents. OpenStack is the selected virtualized infrastructure manager in charge of automating the deployment of VNFs. Finally, a DLT network running in the smart contracts used for the key secret exchange. The deployment consists of 5 VMs running Ubuntu 22.04 hosted on the UPC premises. VM1 contains the Telefonica Alto server, while VM2 contains the UPC ML function orchestrator. VM3 contains an instance of open source Mano as well as an instance of Open Daylight SDN controller. VM4 contains the UC3M DLT network. VM5 contains an instance of InfluxDB and Grafana. 3 OpenStack instances have been deployed, simulating 3 different locations. For the purpose of this demo, a step-by-step script has been developed to show each one of these steps individually. This showcase will cover the deployment workflow and will show the interaction and the messages exchanged. By the end of the deployment, telemetry collected from the data plane will be displayed in a dashboard to demonstrate the correct functioning of the deployment. The MLFO receives a request to deploy an ML pipeline. The request contains information about the data plane network service and the target control plane network service. The MLFO asks the Alto server for topological information. The Alto server returns the mapping between the data centers and their IPs. The Alto server returns the list of possible locations for the agent. Next, the MLFO computes and deploys the network service. The MLFO sends a request to OSM to deploy the VNFs for the NS. The SDN controller configures the network. The agents are deployed in the VMs with Docker. The agents start sending messages to each other to show that the communication has been established. The configuration of the agents ends. The MLFO compiles the smart contract for this network service. Then, it uploads the smart contract to the DLT network. Finally, the MLFO distributes the credentials among the agents. After that, the agents have the rights to access the DLT for that specific smart contract. The MLFO creates a random key and uploads it to the DLT. This key will be used to create the IPsec tunnel between the agents. The agents receive an event every time a new key is uploaded. At that point, the agents retrieve the last key being uploaded by the MLFO. The IPsec tunnel is configured with the new key. Once it is done, all the traffic exchanged between the agents is encrypted. At this point, the deployment has finished. To demonstrate the functioning of the network service, a Grafana dashboard has been deployed. On the top part, the collected telemetry by the agents is showed. On the bottom part, the number of messages sent and received by the agent is displayed. This demonstrates the deployment of a secure mass pipeline to support a network service. This concludes the demonstration. Thank you very much for your attention.